All right, let's look at another concept of events. This time we'll look at the complement of an event. So here what you can see is that we've got a Venn diagram of a single event. So we've got our sample space represented here, and here in the center we have event E. And maybe to make this a little less abstract, let's let this be the sample space will be the outcomes of a six-sided die. And for example, if we let event E be equal to the outcome of a 1 or a 2, okay, then a 1 or a 2 is going to be here. And so if a 1 or a 2 is in event E, what is outside of it? Well, what's outside of event E would be the outcomes of 3, 4, 5, and 6. So the complement of an event is everything else, okay? Everything outside of our event. We use, like an apostrophe to represent the complement of. So E apostrophe would be the complement of E. We could put a bar across the top of an event to represent the complement. Here in this Venn diagram, I've used E apostrophe. So, if event E included the outcomes 1 and 2, then the complement of E would be 3, 4, 5, 6. It's everything else not included in event E. So with this idea of an event and its complement, which is everything outside of it, we can also use these two as a relation between the probability of an event, the probability of its complement, and the probability of the sample space. So in short, the probability of an event plus the probability of its complement will always be equal to the probability of the sample space. Now, the probability of getting anything in the sample space is going to be 100%. And so the probability of an event plus the probability of its complement will always be equal to 1. And you can use this fact, you can use this relationship by rearranging a little bit to calculate probabilities. Because maybe getting this probability of this event isn't straightforward, but getting the probability of its complement is more straightforward. Then you can use the probability of its complement and put that into this relationship, this equation, and get the probability of the event of interest that you're looking for. You can also kind of rewrite this in an equivalent, different way, which would be like the probability of the complement of an event is equal to 1 minus the probability of an event. So, all I did was just kind of switch these two terms. So it just kind of depends on the situation that you're in. Speaking of situations, let's go ahead and look at this through an example. Let me leave this kind of partially up so you can refer to it. So in this example, we're looking at the number of household cats. So a survey of households in an area was conducted to determine the number of cats in each household. So the number of cats could be 0, 1, 2, 3, or 4 or more. The results of the survey are in the relative frequency table here on the right. So if event E is defined this way, so event E is going to be 1 or more cats per household, calculate the probability of E. Now, if we wanted to do this just straightforward with all the things that you've already learned, minus complements, then this is how you do it. So we're looking at the probability of a household having 1 or more cats. So the probability of having 1 or more cats is going to be equal to the probability of having 1 cat plus the probability of 2 plus the probability of 3 plus the probability of 4. So it would be the probability of 1, 2, 3, and 4. So you'd be adding all these up. Okay, now, so you'll get the right answer, but it's just going to be typing in and adding four numbers in. And that's the longer way to do it. But you can shorten that by calculating the probability of having one or more cats, but instead thinking about it in terms of its complement. So the probability of having one or more cats is equal to 1 minus the probability of the complement. And so the complement is going to be owning exactly no cats, right? It's everything that's not in event E. So this would be event E. This one would be your complement. So the probability of having two or more cats is equal to 1 minus the probability of having 0 cats. And we know that the probability of having no cats is 0.35. So 1 minus 0.35 is 0.65. So, this is a simpler calculation than doing all of this. So this is how you can use this relationship that we talked about before with the probabilities of an event and the probabilities of its complement being equal to 1 in order to solve problems. So kind of using this as a model, try and solve this think, pair, share. All I did was change the event just a little bit. You could do it straightforward, but try and do it in terms of what we talked about with the complement. So go ahead and pause the video here and give it a try. Okay, so hopefully you went ahead and gave this a try. Let's go ahead and work this out together. So same survey as above, but event F is going to be 2 or more cats. So the probability of F, if we're going to think of this in terms of the complement, is going to be 1 minus the probability of the complement of F. And so the probability of the complement of F would be the probability of, let's see here, having 0 cats and the probability of having 1 cat. So let's see here. The probability of having 0 cats is 0.35. And, oh wait, I just read that wrong. This is 2 or less. So that means this is going to be 3 or more. So that's going to be 3 and 4 plus. Okay, so hopefully you kind of had some alarm bells going on as I was doing that. Okay, let's keep going. So the probability of having 3 cats is going to be 0.07. And the probability of having 4 or more cats is 0.02. And that's going to be 0.09. So that's the probability of the complement. So, oops. So what we can do, oops, let me get rid of that. There we go. Is we can take this value, plug it in here. So the probability of having 2 or less cats is going to be 1 minus 0.09, which is 0.91, or 91%. So that appears to be correct. Let me know if you have any questions.